Good morning, ladies and gentlemen. My name is Zheng, and today I'll be your host. I'm sure you all have heard about the debate between the wave theory and the particle theory. Well, what do you think? Do you think light is a wave, or do you think light is a particle? Well, let me tell you a little something. Light is a wave. With me here today is Cesar, Jessica Coreas, and Jeffrey Galicia. This controversial topic dates back to the time of Christiaan Huygens, an ingenious scientist who first came up with the wave theory. Without further ado, I will now turn my spotlight over to Jessica Coreas, as she will continue talking about Christiaan Huygens.
Christiaan Huygens was born April 14 in 1629 into a rich Dutch family. He died on July 8, 1695 because he suffered serious depressive illnesses. His father wanted him to study law, but Huygens wasn't interested. He instead became a mathematician, a physicist, and an astronomer. Huygens also discovered the pendulum clock, centrifugal force, and Saturn's true rings, as well as its moon Titan. He came up with the wave theory, also known as the undulatory theory. Initially, he meant to prove Isaac Newton's corpuscular theory. He met Isaac Newton in the Royal Society and admired him greatly.
Wow, Christiaan Huygens is such a genius. If only I was half as smart as him. Anyway, before we get into the good stuff, shouldn't we talk about the wave theory? Welcome, Jeffrey Galicia.
In 1678, Christiaan Huygens believed that light was made up of waves vibrating up and down perpendicular to the direction light traveled. This helped formulate a wave to visualize how waves moved around space. This became known as the Huygens principle, which I think is tremendous compared to Newton's idea that light is made up of particles. Another point is that light is part of the electromagnetic spectrum, which is composed of light, gamma rays, X-rays, microwaves, and radio waves.
Was that cool or what? Anyway, that kind of got me thinking of, since light is a wave, then shouldn't the properties of light be similar to the properties of wave? Well, let me tell you a little something about light first. Light, as a form of electromagnetic radiation, is a fraction of the total energy emitted by the sun. The light we see, visible light, is measured in wavelengths. There are so many properties of light, but today I will only mention a few of the most important ones. 1. Speed of light. Light travels at a speed of 300 million meters per second in a vacuum, but when the light enters a medium, then the speed obviously decreases. Well, how much slower? That depends on the type of medium and its density. For example, in water, light travels 30% slower in water than in vacuum because water is obviously more dense. Next, refraction. Refraction is the bending of light as light enters from one medium to another. For example, if we take a glass beaker, and we fill it up with water, and then let's just say we insert a pencil into the beaker, our human eye wouldn't see a straight line because the object appears to be bent since the two mediums are not the same. Water is denser than the air outside. Next, dispersion. Dispersion is when white light breaks into multiple colors. For example, I'm sure you all have seen the prism with one side being white light and the other side being multiple colors. That is called dispersion. Next, diffraction. Diffraction is the bending of light as light enters a aperture. Once it enters the aperture, light bends around the aperture to spread out the light rather than just focus on one particular area. Interference is when two beams of light meet. There are two types of interference: constructive interference and destructive interference. Constructive is when the two lights become brighter, and destructive is when the two lights become less bright. Last but not least, light also goes through the Doppler effect. That was so much work. Anyway, before we all run out and tell everyone that light is a wave, don't you want to hear what Cesar Roucco has to say? I think that's a yes. So welcome, Cesar Roucco.
We all know that waves are vibrations. So, for light to be a wave, something has to vibrate. Since waves are caused by the vibration of particles, waves are the energy created by vibrating those particles, not the particle itself. Just like Jason talked about some light properties, Light also exhibits the Doppler effect, which is a shift of wavelength. Sound travels at a constant speed through air, just like light does through a constant medium. Moving it back and forward changes the frequency which the source is emitting those waves. In sound, that changes the pitch. In light, that changes the color. Now, just like Jason talked about refraction, we know that light is bent when it's refracted by a substance. Now, if light were composed of a stream of particles, those molecules from the substance would attract the particles of light, making it move faster, which is not true because light moves slower when it crosses a denser medium. Also, if light were consisted of a stream of particles, when wave interference happens, like Jason mentioned, the particles would collide with each other, causing a deviation in the light beams, which is not true because there exists wave interference, either constructive or destructive.
Well, thank you so much for tuning in with us today, and I hope you have a great day. Remember, light is a wave, not a particle.